Hi students, welcome to Max Point of View. Today we are going to solve each and every previous year questions from the chapter Work Power Energy, and we know we are going to start from 2017 to 2025. Why not before 2017? Because the syllabus different and the questions were very simple, logical questions were less. Now you know at the current situation logical questions are more and direct questions are less. Before watching this video, my suggestion is to watch the concept, theory and numerical videos of all the parts of work, energy, power. Then only this previous year paper will be useful for you. If you just going to look for what type of questions, then it is okay. If you're looking for a knowledge, so first gain the knowledge from the textbook. Concept, first we have three parts of work, energy, power. All the three parts concepts, all the three parts solutions, theory solutions, all the three parts numericals. Once you understand all those things, then this video will be helpful for you. What is the main advantage of these previous year paper videos? We are going to analyze how the question papers are completely different from textbook questions and in which way the same question can be twisted in other ways, so that we are going to get the complete knowledge in all the angles. So without wasting any time, we'll start with our first question. Our first question in 2017, if the power of motor be 100 kilowatt, at what speed can it raise a load of 50,000 Newton? Very simple question if you know the formula. See here what they have given, power is given. Power is equal to 100 kilowatt. Okay, then we have to find the speed. Speed is nothing but velocity. We take it as velocity, symbol V. Here V is equal to question mark and force is given. It can raise a load of 50,000 Newton. What is that 50,000 Newton? Newton is nothing but force, correct? Force is equal to 50,000 Newton. So what is the formula? If you have seen the numerical videos, then this is a very simple formula. P is equal to F into V. So what we want? We want V. So V is equal to P by F. Then V is equal to, what is P? 50,000. No, P is 100 kilo. 100 kilo. What is kilo? Kilo means 1000 divided by 50,000. For 4 zeros get cancelled. 5 ones are 5 twos are. Answer will be 2. So if you write like this, you will not get full marks. Assume maximum question for this mark question will be 1 or 2. If it is for 1 mark, you will lose complete 1 mark. If it is 2 marks, you are going to lose last 1 mark. Why? Because you got the answer. Who will write the unit? What we are finding, that is, so velocity. Velocity unit will be meter per second. See, in ICSE, every unit carries 1 mark. Assume there is a 4 mark numerical. A, B, C, D, there are 4 sub questions. All your A, B, C, D answers are correct, but you have missed units in all the sub questions. Then all the 4 marks you are going to lose, because every unit carries 1 mark. Now we'll move on to 2018. State and define the SI unit of power. So what we have to do? Define the power and we have to state it SI unit, correct? Completely wrong. Why? Because see the question properly. State and define the SI unit of power. So we have to state the unit of power, SI unit of power, and we have to define that unit. not defining the power. So understand the question. So how this question is different from normal question? Define power and state its SI unit. That is completely different. There we are going to define power and state its SI unit. Here state and define the SI unit of power. That means we have to state the unit of SI unit of power and we have to define that unit. Okay, be careful. So first state, right? So what is the SI unit of power? That is watt. How we can define this unit? 1 joule of work is done in 1 second, because power is equal to, okay, power is equal to what? Work done by time, right? So how we can define the unit? 1 joule of work is done in 1 second is said to be 1 watt of power is spent. So like this we have to define. So this is done, part A is done. We'll go to part B. What is that? How is the unit horsepower related to SI unit of power? Okay, what is the SI unit of power? Watt. How that is related to horsepower? What is horsepower? Horsepower is nothing but HP. So 1 HP is equal to 746 watt. So this, there is no need to understand anything, we have to by heart. Our next question, state the energy changes in the following cases while in use. While in use, first one, an electric iron. Electric iron, what is the energy change? Electric iron means what? From because of electricity it is running, correct? So the source is, see, when it comes to these kind of energy changes, you have to see what is the input and what is the output. What is the input means what is the source we are giving? Electric iron, the source will be, input will be electricity, so it is from electricity, okay, electric energy. To why we use electric iron? For heating purpose, correct? Okay, you can write it as to heat energy. Second one, ceiling fan. Ceiling fan is nothing but the normal fan only, that runs because of electricity again. So electric energy. So what we are getting? We are getting air, correct? So air energy, correct? No. So what it is happening there? What's happening there? It's moving. Whenever it is moving, we call it as mechanical energy. Mechanical energy. That's it. So whenever these kind of questions are asked, you have to think about only two things. Okay. So first, what is the input given? Second, what is the output we are getting? So input in electric fan is electrical energy. Because of electricity it is running. Okay, whenever something is moving part, so we call it as mechanical energy. Our next question, name the unit of physical quantity obtained by the formula 2k by v square. See, this formula they have given. Okay, we have to get the physical quantity, correct? No, we have to get the unit of that physical quantity. See, what is K? K represents kinetic energy. V represents velocity. So it is related to kinetic energy and velocity. So what is the formula for kinetic energy? Kinetic energy is equal to half mv square. This is how you are going to get the answers. So first you need to understand it is related to what? Kinetic energy and velocity. In these two are related using the kinetic energy formula. First you have to get the formula. Next, what do we have? We have 2, we have k, we have v square, correct? See, I will move this to this side, this to this side, then this becomes 2k, then I'll move this v square that side, okay, LHS, that becomes v square. So what is remaining here? Mass. So mass is the physical quantity we are looking for. Okay, but are they asking name the physical quantity? No, they are again twisting the question. Name the unit of this physical quantity. What is the unit of this physical quantity? That is kg. So answer for this question is kg. Okay, see, this is very much important. So we'll try to understand one more time. This is the formula they have given. So in this formula, what is this? K is kinetic energy, V is velocity. So kinetic energy and velocity is related using the kinetic energy main formula. So in the formula we have 2k v square. What is remaining? M. So we'll move all these things this side. We'll get to know whether we are going to get the same formula or not. So I'll move this 2 this side, it becomes 2k. I'll move this v square that side, that means LHS. So it becomes 2k by v square, the same thing as the question. So what is remaining? Mass. Mass is the physical quantity. So what is physical quantity? Anything which can you measure. So if you can measure mass, physical quantity. Density, physical quantity. Force, physical quantity. Whatever the things we can measure, all those things are physical quantity. Earthquake also we can measure, correct? So earthquake is also a physical quantity. Then all those things, okay, now in this question they are not asking name the physical quantity, name the unit of physical quantity. So this physical quantity is mass. What is the unit of mass? That is kg. We'll take one more example to understand this one better. Okay, see the given, assume this is the given formula in the question, W by P. Okay, W by P is the formula given. We have to name the unit of physical quantity. You have to be very careful whether they are just asking the physical quantity or unit of physical quantity. In unit you have to be very careful. Physical quantity means direct answer will get. See, W means work. Okay, work done. P means power. So these two are related using the formula power is equal to work done by time. So to get, see, these two are related using this formula. So how is this arranged? So P is here, okay, P is in denominator. So P, if P wants to be in denominator, this has to move this side, right? Time has to move LHS. So time becomes work done by power. The same question as given in the question. So what is the physical quantity we are looking for? Time. What is the unit of time? The answer is second. This is how you have to tackle. Our next question, derive a relationship between SI and CGS unit of work. What is the SI unit of work done? That is joule. CGS, what is the CGS unit of work done? That is erg. Okay, so they are not asking write the or state the SI and CGS unit of work. We have to write the relation between them. So 1 joule is equal to how many ergs we have to write, that is 10 power 7. Keep this in mind. 1 joule is equal to 10 power 7 erg. So this is the SI unit and this is the CGS unit and this is the relationship they are looking for. This is sub question A. We'll go to sub question B. A force acts on a body and displaces it by a distance. Okay, a force is applied and the object has moved to a certain distance, that is S, in a direction at an angle theta with the direction of force. In the direction of, see, if you understand this question properly, okay, so displaces it by a distance S in a direction, in one direction at an angle theta with the direction of force, with the direction of force. What do you mean by that? So with the direction means in which direction force is applied, in the same direction object is moved. So understanding the question is very much important here. Okay, so they are not telling the displacement of an object is in different angle compared to the force applied. They are saying the displacement of an object, okay, how much it has moved. It is moved in the same direction in the applied force. Okay, whatever in which direction I have applied the force, in the same direction the object is moved. See, like this, I have applied the force like this, object is moved in the same direction. So what will be the angle between them? The angle between them will be 0. Now we'll go for the question. What should be the value of theta to get the maximum positive work? See, maximum positive work we will get at an angle theta, sorry, 0. Okay, at an angle 0. Why? Because what is work done? Work done is equal to Fs cos theta. Correct. So Fs, the values will be given, correct? Assume whatever the value you get, you take it. So we don't care about, whenever we talk about positive work done, negative work done or 0 work done, we don't care about Fs, we care about cos theta. Okay, what is cos 0? Cos 0 is 1. 1 into anything will get the same answer, that will be positive, correct? So for positive work done, okay, for positive work done, okay, the theta value should be equal to 0. Okay, for negative work done, okay, theta should be 180 degree. Okay, theta here is 0 degree for positive. For zero work done, okay, theta should be 90 degree. Keep this in mind. This is what we have learned in concept video theory solutions, correct? So here also we are getting that this is just a glimpse. So for positive work done, theta should be 0. Negative work done, so negative work done angle should be equal to 180 degree. What do you mean by that? The object is moving in this direction, but the force applied in this direction. How this is possible? This is only possible when we talk about friction. Friction is always in the opposite to the direction of movement of an object. Keep that in mind. Whenever they talk about friction, the angle will be 180 degree. If the angle is 180 degree, work done will be negative. Next, so theta, if theta is 90 degree, okay, the angle between the force applied and the displacement is 90 degree, then the work done will be 0. Why? Because what is work done? Fs cos theta. Okay, if theta is equal to 90, what is cos 90? Cos 90 is equal to 0. Anything multiplied by 0 will be 0. That's why work done will be 0 when it comes to 90 degree. That is possible in when the object is moving in a circular path. When it is moving in a circular path, so the angle between the force applied and the displacement is always 90 degree. That's why circular path, in any circular path, work done will be 0. Now we'll move on to 2019. Two bodies A and B have masses in the ratio 5:1. Mass ratio, okay, mass is equal to 5:1. Then their kinetic energy are in the ratio 125:9. 125:9. Find the ratio of their velocity. We have to find the ratio of their velocity. So how we can solve it? It's a very simple question. If you apply the formula, substitute the values, you will get the answer. So can I write this ratio in the form of fraction like 5:1 as 5/1? Correct. In the same way, kinetic energy ratio is 125:9. That means there are two kinetic energies. Their ratio is 125:9. That means 125 divided by 9. So first kinetic energy, see, we'll write it like this. There are two kinetic energies. We'll write it as kinetic energy A, B, and in the bodies also they have mentioned, but two bodies A and B. So we can take it as a kinetic energy A, kinetic energy B. So it is, what is kinetic energy formula? Of mass of A and velocity of A square. In the same way, half mass of B, velocity square of B. Okay, this is very much important. The square you should not miss. Okay, so now substitute the values. So this is mass of A and this is mass of B. This is kinetic energy of A, this is kinetic energy of B. Substitute here. So kinetic energy of A is 125 divided by kb, kinetic energy of B, that is 9. Next, half and half, it will get cancels, correct? So we don't have to write it. See, these two will get cancels here. We don't have to write it. Then remaining thing is mass of A. What is mass of A? That is 5 into VA square. We don't know velocity of A, that we are going to find. Then what is mass of B? Mass of B is nothing but 1, that is 1 VB square. Okay, now we'll transpose all these things. Okay, so we'll send this 1 here and 5 here. This becomes 125 divided by 9 into 5. So why I have not multiplied it? Because if you multiply it again, it becomes a bigger number. Again you have to divide it. So 5 ones are 5, 25s are. So it is nothing but VA square by VB square. So how can I write it? See, this 25 and 9. So 25 by 9. Do we want VA square and VB square or VA by VB? We want just VA and VB. We'll send this both the squares that side. Okay, so it becomes square root. Correct. If you send these two squares this side, see, because of this square, this 25 become root 25, and because of this square, this 9 becomes root by 9. All the same thing we have done. Then it is VA by VB. VA by VB. Now what do we have? So square of, so I'll write it here, VA by VB. So what is square root of 5? 25, that is 5. What is square root of 9? That is 3. So VA is to VB. So initially I wrote it as 5 is to 1 as 5 by 1. Now VA by VB will be equal to VA is to VB. That will be equal to 5 is to 3. That's it. See, these kind of questions look something like some calculation, more calculation, but if you know the method, you don't have to remember the steps, right? So we are just substituting the values as it is, okay, and cancelling whatever it is same, we are going to cancel. Assume if they have given, if the masses are same, then we are going to cancel masses also. Or if they mention velocities are same, then we'll cancel velocities also. Then remaining things we are going to find the values. So if you get any confusion or any doubt, just go back a bit, rewatch it, you will definitely understand. Our next question, name the physical quantity which is measured in calories. So calories is one of the units of energy. So answer for sub question A is energy. It's not work done, it is energy. Second question, how is calorie related to the SI unit of that quantity? What quantity? Energy is the quantity. What is the SI unit? See, a calorie is one of the unit. SI unit of energy is joule, correct? So SI unit is joule, and they have given one more unit is, that is calorie. How these two are related? That means what is the relation between these two? See, 1 calorie is equal to, so CAL is the short form of calorie. 1 calorie is equal to 4.18 joules. 4.18 joules, or you can write it as 4.2 joules. Okay, or else you can write like this: 1 joule is equal to 0.24 calorie. You can write any one. Okay, this is optimal. Why? Because in ideal case, see, why this is correct compared to this one, both are same only, but how this is correct? Because how is calorie related to SI unit? How much is 1 calorie is joule? That is the way they are asking the question. So this is the proper answer. You can write this one, so there will be a confusion, okay, for the person who is correcting the paper. That's why, in order to remove the confusion, first see what unit they have mentioned. Calorie. So first unit should be calorie. 1 calorie is equal to how many joules? You write like that. Our next question, a body of mass 10 kg. So what they have given, body of mass, so mass is equal to 10 kg at a height of 5 meter. Okay, is kept at a height. So the total height from the ground level is 5 meter. Then it is allowed to fall and reach the ground. Okay, it is going to fall. Okay, assume the ball is here and the ground is here. The total height is 5 meter, and what is the mass? That is 10 kg. So 10 kg of an object, okay, any object is which is kept at a height of 5 meter. Now it is made to freely fall. Okay, this is the concept. So this ball is going to fall in this direction. The total height is 5 meter. Now what is the total mechanical energy possessed by a body at a height of 2 meter, assuming that it is in frictionless medium? Okay, see, so when the body is at height of 2 meter, when the body total height is 5 meter, when this ball freely falling, or when this body is freely falling, whenever it is somewhere here, where there is the remaining height is 2 meter, what is the total mechanical energy? See, if you know the concept, you don't have to calculate all these things. Very simple. See, first this concept, I'll teach you the complete concept, then you will understand. Whatever the question they ask, you can easily answer. See, when the body is kept at 5 meter height, that means it is not moving. So if it is not moving, kinetic energy will be 0. U will be mgh. So mgh, in this question G value is given as 10. Okay, so m is nothing but 10 kg into 10 into h. What is h? The total height, it is 5. So it is 100 into 5, 500 joules. For kinetic energy, unit is joule. For potential energy, unit is joule. For mechanical energy, unit is joule. So whatever the words ends with energy, the unit will be joule only. So see, first thing, when the ball is here, kinetic energy will be zero. Potential is maximum. Why kinetic energy be zero? For kinetic energy, the object has to move. In the question, it is clearly mentioned the object, okay, of mass 10 kg is kept at a height. It is not moving. It is kept. So before falling, the kinetic energy will be zero. Potential energy will be maximum. And now listen, when the object is about to reach the ground, assume the object is here, about to reach the ground. Here, height will be zero. If height is zero, okay, what will be zero? Potential energy. See, for potential energy, we have to think about the remaining height. See here, listen, one more thing. This is very, very important. Whenever the ball is falling, okay, assume it has covered till here. Okay, assume it has covered 1 meter. So assume it has covered 1 meter. So to find the potential energy at this point, we should not include this 1 meter. Potential energy depends upon the remaining height. Keep this in mind, remaining height. If 1 meter is done, the remaining height is 4 meters. So to find the potential energy, mass remains same. So what is potential energy formula? mgh. Mass and gravity remain same, 10 into 10. But what about the height? Height will be remaining height. You should not take this 1 meter height. Assume you get some value. Okay, assume we'll go for calculation only. Okay, see, all these things are not related to this question. This is the complete explanation. I will give you the answer for these questions also. Okay, first we'll understand the complete basic, then you will understand the question. If this question or any question they ask, you can easily answer it. Assume the ball is here, it has crossed 1 meter. What is the potential energy if it is a frictionless medium? If this is the question, apply the formula. U is equal to mgh. Okay, mgh, what is m? 10 into gravity 10. What is the height? Height, you should not take the covered height. Height should be, when it comes to potential energy, it should be always the remaining height. Remaining height is 4, right? So answer will be 400 joules. Okay, then kinetic energy, you don't have to calculate, you can write it as 100 joules. Why I am writing, how I am writing 100 joules? Very simple. At initial value, okay, initial value, okay, whatever the initially, when the ball is here, okay, we have kinetic energy 0, potential energy 500. Now potential energy is 400. How much is lost now? Initially potential energy is 500, now it is 400. How much is lost? That is 100. That will be kinetic energy. So when the object is moving down, potential energy keeps on decreasing because height is getting decreased. How much potential energy is decreasing, that much kinetic energy will increase. If the 30% potential energy is lost, that means 30% kinetic energy is gained. So how much is lost in potential energy, that much will be gained in kinetic energy. So before reaching the ground, height will be 0. If height is 0, potential energy is 0, because potential energy depends upon mgh. Mass will be 10, gravity will be 10. What about height? Height will be 0. Anything multiplied by 0, potential energy will be 0. If potential energy is 0, I told you how much potential energy is lost during the journey, that much kinetic energy will be gained, correct? Okay, initially it was 500, now it is 0. How much lost? Okay, I have to always compare with the initial value only. Okay, so initially it has 500 joules, now it is 0. How much is lost? 500. So kinetic energy will be 500 joules. 500 joules. Next, we'll talk about total mechanical energy. What is total mechanical energy? Mechanical energy is nothing but a sum of potential energy and kinetic energy. At every point, total mechanical energy remains constant. Why? Because we know how much potential energy is lost, that much kinetic energy is gained. Okay, so 30% here it is lost, potential energy is lost. So assume 30% potential energy is lost, and we know how much it is lost, that much gain in kinetic energy. If 30% potential energy is lost, that means 70% potential energy is there. Then how much it is lost? 30%. So this is U and this is K. So if 70% is there, remaining is 30%, that will be gained by kinetic energy. Whenever we add, at every point mechanical energy remains same. Every point mechanical energy remains same. So what is the mechanical energy? Very simple, you can take any point. You will always go for the first point only because it is easy to calculate. First point, what is the kinetic energy? 0. Potential energy 500. 0 plus 500, 500 joules. Second point here, see, assume it has covered 1 meter. 1 meter distance. Now what is the potential energy? We calculated, right? For this remaining height, that is 400. Kinetic energy 100. 400 plus 100, again 500. We'll go for last step. So here potential energy is 0, kinetic energy is 500. 0 plus 500, 500. So every point, if it is a frictionless medium, this is very much important. If it is a frictionless means the energy is not lost. Okay, in that case mechanical energy remains same at every point. See, this is not the solution for this particular question. This is the complete concept. Now we are going to answer according to the question. See, first if we have all these knowledge, we can answer all these questions in a easier way. I'm going to teach you how to answer these kind of questions in an exam in easy method by saving so much of time. Listen, once we have this knowledge, you don't have to do all these things in the exam. Okay, first thing you are going to do in the exam is finding this point, finding this answer. Okay, always you have to do this one. Okay, what we are going to find? We are going to find the kinetic energy and potential energy when the ball is at rest. When the ball is at rest, we need to find kinetic energy and potential energy. So kinetic energy, we know it will be always 0 because it is not moving. For how to find potential energy? Potential energy is equal to mgh. Mass, gravity, everything will be given. Height, we have to always calculate the potential energy for the remaining height. If the ball is not moving, the complete height is the remaining height. So using all those things, we will find the potential energy. Once you find potential energy and kinetic energy, we know at every point mechanical energy remains same. That you should know. Okay, now once we find this one, you don't have to calculate all these things, only for the first position. Once you solve this one, directly we will go for the question. So sub question A, what is the total mechanical energy possessed by the body at the height 2 meter? Okay, assuming it is a frictionless medium. Assume the ball is here somewhere. Okay, the remaining height is 2 meter. For this, we need to find the total mechanical energy. We know mechanical energy remains constant. Okay, if it is a frictionless medium, this is very, very important. Okay, frictionless medium is the keyword here. If the medium has friction, then I'll teach you how to do that. Okay, now for the remaining 2 meter, we need to find out mechanical energy if it is a frictionless medium. This is very much important, frictionless medium. So if it is a frictionless medium, at every point mechanical energy remains same. If it is 2 meter, 1.5 meter, 1.8 meter, 3.3, 4.9, all these heights, okay, mechanical energy remains same only if it is a frictionless medium. Now listen, at A is at 2 meter, correct? 2 meter we need to find the answer. So before going to the sub question, we need to find the kinetic energy and potential energy, okay, when the ball is at rest. Okay, for this point we have to find this one. Once we find this one, directly we can go for the question. Okay, see, first we will find the potential energy. How much ever we find the potential energy, we will subtract with the initial value, then that will be the kinetic energy, because we just now we have understood how much potential energy is lost when the ball is moving down, freely falling. Potential energy will keep on reducing because the height is reducing. So as the potential energy keeps on reducing, that much kinetic energy will be gained. So if the potential energy is lost 30%, kinetic energy will be gained by 30%. So if 200 joules is lost, okay, assume at this point, okay, when the ball is here, 100 joules of potential energy is lost. 100 joules of potential energy. How much it has now? How much potential energy it has? It has 400. How much it is lost? 100. So at this point, okay, potential energy will be 400. Then kinetic energy will be 100. When we add these two, we should get 500 for the comparing to the initial position. The same answer we should get. Okay, now we are going to calculate it for 2 meter. That means the remaining height is 2 meter. So here mgh, what is m? 10, g 10, height is 2, so it is 200 joules. Okay, if potential energy is 200 joules, kinetic energy will be 500 minus 200, that will be 300 joules. How I could answer right? Kinetic energy as 300. See, initial value, the complete mechanical energy K plus U is 500. See, at every point K plus U remains same, mechanical energy remains same. So here the complete value mechanical energy 500. How much potential energy we have 200. How much it is lost? 300 joules we have lost at 2 meter height. So how much we have lost? That much will be the answer for kinetic energy. That's it. Next, we'll go for sub question B. What is the kinetic energy possessed by the body just before hitting the ground? Just before hitting the ground. Just before hitting the ground means this position. We know whenever the ball is about to reach the ground, height will be 0. If height is 0, kinetic energy will be 500 joules. Why we are taking it as 500? Because initial value. This is very much, always calculate the initial value. Then using that everywhere we are going to calculate the remaining answers. So before reaching the ground, you have to mention just before reaching the ground. Okay, height will be 0, so potential energy is 0, so the complete energy will be 500 joules. Kinetic energy will be 500 joules. That's it. Now we'll go for the different kinds of question. What if? Find the total mechanical energy possessed by the body at a height of 2 meter or any height. Okay, assuming 20% of energy is lost as friction. 20% of energy is lost as friction. Now this is a serious thing. Okay, because initially it was frictionless. Now it is 20% energy is lost. So we know mechanical energy remains same at every point. Mechanical energy remains same at every point. So for this question, mechanical energy is 500 joules. What is 20% of 500 joules? 100 joules. So remove that, final answer will be 400 joules. Understood? See, the same question, sub question A, find the total mechanical energy possessed by the body at a height of 2 meter. Okay, here the total mechanical energy for this question is 500 joules. Okay, 500 joules. Okay, now this is the answer for the first sub question. The same question, if they mention 20% of energy is lost because of friction, then we have to remove the 20%. See, 20% is lost, that you should not calculate. 20% is lost because of friction. How much is remaining? 80%. We can do one thing. 20% of this one is 100 joules. Remove that 100 joules. Answer will be 400 joules. Or else you can do one more thing. 80% of 500 joules is 400. That will be your final answer. You can do in any ways. That is how you need to answer. You have to write it in sentence form. So for this is the final mechanical energy is 500 joules. 20% is lost. For 20% of 500 is 100 joules. So that is lost. The remaining energy will be 400 joules. Or 80% of 500 joules is 400 joules. You can also write that directly. So in this way we need to understand. And one more thing, they are going to play with you with this word. Okay, conservation of mechanical energy. Okay, conservation of mechanical energy. See, what is the first thing about conservation? Whenever the energy changes between kinetic energy to potential energy, the total energy remains same. That means here at every point kinetic energy and potential energy are changing, but the total mechanical energy remains same. This is nothing but conservation of mechanical energy. What is the condition for this? For the conservation of mechanical energy, the medium has to be frictionless. The medium has to be frictionless. Then only conservation of mechanical energy takes place. Now we'll move on to 2020. Give one example of each one. Chemical energy changes into electrical energy changes into sound energy. See, for this question you can give any example. It should be proper, okay, appropriate. And there is no rule that whatever examples I give, you have to give the same thing, because the same question if you get, you can give. If in the exam we know the questions are not going to repeat, so here we are going to get the knowledge how to answer the questions, then you can answer accordingly. Okay, so first question, chemical to electrical. There are many things are there, but very simple example is our mobile phone. Okay, mobile phone while charging means we are giving electricity to the battery inside the mobile, correct? So electrical energy, giving electricity is nothing but input. What is the output? The electrical energy is getting stored in the battery in the form of chemical energy. So that is electrical to chemical, but here they are asking for chemical to electrical. While charging it is electrical to chemical. While using, whenever you are using the mobile phone, the stored energy is converted into electrical energy. That is an example for this question. Okay, while using mobile or laptop. Okay, because while using, the stored chemical energy in the battery will be converted into electrical energy. Second one, electrical energy changes into sound energy. Speaker. loudspeakers. Okay, few students will try to answer this question. Okay, so electrical to sound as mic as an example. Mic is completely wrong. Mic, what we are giving? We are giving sound energy. Sound energy is getting converted into electrical energy, but here they are asking electrical energy to sound energy. So speakers, output should be sound, output should be sound, input should be electricity. That's it. Our next question, a crane A lifts heavy load in 5 seconds, whereas another crane B does the same work in 2 seconds. Compare the power of crane A to that of crane B. Here, the important things, first I'll write it down. See here, the crane A, okay, crane A takes how many seconds? 5 seconds, and crane B do the same job in 2 seconds, and we need to compare their powers. Power of A is to power of B. We need to find the answer. See, in some questions you have to be very careful. Comparison, when it comes to comparison, sometimes they may change the question at the end, like this: compare the power of crane B to that of crane A. See, in that case we need to find power of B is equal to power of A. See, you need to understand the difference between these two. Okay, see, this is the actual question. This is what we are going to find in this question. What if they change the question like this at the end? You should not always read the question, okay, just like that. You have to understand it. Compare the power of crane A to crane B. Then this is what we are going to find. If they change the question, compare the power of crane B to crane A, then we have to find this one. So how to find these two, I'm going to teach you at the end. Don't worry. See, first, both are doing the same work. So work done by A is equal to work done by B. This is what we need to understand. In this way, if you write, answering these kind of questions are very easy. See, power of A is equal to power of crane A is equal to work done by A by time taken by A. What is work done? Work done, we don't know the value, but they have given the work done as same, so we don't have to write work done of A, because both work done of A and work done of B are same. We can write W by TA. What is the time taken by A? That is 5 seconds. Then power of B is equal to work by time taken by B. Work remains same, we don't know the value, we'll write it as it is. Time to, what we need to find? PA is to PB. According to this question, we have to find PA is to PB. PA by PB. See, PA is to PB is nothing but PA by PB. Okay. If it is in ratio, we can write it in fraction. So what are the answers? WA or W, because both the work done by the crane A, crane B is same. W by 5, here W by 2. If you write it like this, instead of division, we'll write it like this. We'll take the reciprocal of second one. W get cancelled. The answer will be 2 is to 5. So this will be PA is to PB is equal to 2 is to 5. This is the required answer for this question. If they change the question, compare the power of crane B to that of crane A, then answer will be PB is to PA will be 5 is to 2. Okay, that's it. Our next question, the figure below shows a simple pendulum of mass 200 grams. So what is the mass of this pendulum? 200 grams. So it has to be converted to SI unit. Keep that in mind. So that is 0.2 kg. Mass should be 0.2. If you take 200 everywhere, you will get all the answer, but everything will be wrong. It is displaced from the mean position A to the extreme position B. The potential energy at the position A is 0. At the position B, pendulum bob is raised by 5 meters. So that's okay. We can arms go for the solution properly. Before that, we need to understand the concept. What is mean position? What is extreme position? Listen. Mean position means height will be 0. See, it's not like whenever we talk about a freely falling body, okay, for a freely falling body, what is the height we are going to take? The complete height, the remaining height from the ground level, correct? This we take it as the height, correct? But when it comes to pendulum, height is not from the ground level. Okay, height means from the center of the bob. From the center of the bob to the maximum height. If the bob reaches here, from the center of the bob to the center of the bob at this position, what is the height? That is 5 meter. So this concept you need to know. Okay, this is what we have learned in concept video of work energy power part C. Correct. So here height, what is the height? Height is nothing but not from the ground level, from the center of the bob at mean position. What do you mean by mean position? Mean position means when the bob is at center. Okay, when the bob is at center, height will be 0. Keep this in mind. Height will be 0. If height is 0, potential energy is equal to 0. The remaining thing will be kinetic energy. So the sum of potential and kinetic energy will be mechanical energy. So these things you should know. Okay, at a mean position, height will be 0. U will be 0 because potential energy depends upon height. If height is 0, potential energy will be 0. Everything will be kinetic energy. As the bob rises up, okay, displaces, the height keeps on increasing. Height keeps on increasing. If height keeps on increasing, potential energy keeps on increasing. So what is getting lost? Kinetic energy. See, when it comes to kinetic energy and potential energy, they'll keep on changing. If potential energy increases, kinetic energy keeps on decreasing. This is when it is a frictionless medium. When it is a frictionless medium. Now assume it is a frictionless medium. So here at this point potential energy is 0, kinetic energy will be maximum. Okay, then as the bob displaces, as it moves, height keeps on increasing. If height keeps on increasing, potential energy keeps on increasing. At this point, extreme position. What do you mean by extreme position? Extreme position means when the bob is displaced, okay, when it is start oscillating, the maximum, okay, height it can reach, the maximum height it can reach. When it reaches the maximum height, potential energy will be maximum at, okay, this is very much important, at this one extreme ends. Say mean position, U will be 0, kinetic energy will be there. At extreme position, K will be 0 and U will be maximum. This we should know. Okay, at extreme position, K will be 0, U will have something. Okay, why K will be 0? Why? Because whenever it moves like this, okay, why it is coming back to the same position? It has to go, it is going like this. Why it is coming back? Why? Because whenever it is moving, it has some velocity. So kinetic energy will be there until it has velocity. And why it is coming back? Why? Because whenever the velocity becomes empty, because it is connected here, it comes back. Because it is connected, it comes back. So at this point, extreme position, keep this in mind, kinetic energy will be 0. Why? Because there will be no velocity. And the height will be maximum. Height will be maximum. So the complete kinetic energy what we had here, that will be converted into potential energy, and whatever the potential energy value we have, that will be converted into kinetic energy. That's it. So at mean position, U will be 0, potential energy will be 0, kinetic energy will be maximum. At extreme position, kinetic energy will be 0, U will be maximum. Apart from these two positions, anywhere, here, we have both kinetic energy and potential energy, and at every point we know mechanical energy remains same. Whatever it happens in this direction, the same thing happens here. So at mean position, potential energy is 0, kinetic energy will be there. The same bob, when it reaches the extreme position, maximum displacement it can have, at that point, okay, kinetic energy will be 0, potential energy will be maximum. This is the concept. If we know this concept, then we can aramse solve these given question. Now we'll go for the question. What is the potential energy of the bob at position B? At position B, we know if they ask what is the kinetic energy of the bob, okay, of the pendulum at position B, kinetic energy at B will be 0. These things we should know. Okay. So anyhow they are asking for potential energy, we'll find potential energy. If they ask kinetic energy, answer you can directly write it as 0. Why? Because at extreme position, okay, velocity will be 0. So kinetic energy will be 0. At extreme position, height will be maximum. So potential energy will be maximum. So we need to find position at B. At B, U is equal to mgh. mgh. What is m? Mass of the bob, that is 0.2, g given as 10, height at extreme position B, height is given 5 meter. So 5, 10 5s are 50, 50 into 0.2, 10 joules. Done. We'll go for sub question B. What is the total mechanical energy at point C? We know at total mechanical, what do you mean by total mechanical energy? Mechanical energy, total means sum of potential and kinetic energy. See, here we don't have to calculate. We can aram se write, see at extreme position, here we have calculated potential energy. How much? 10 joules. Kinetic energy 0 joules. What is the mechanical energy here? 10 plus 0, 10. So mechanical energy remains same at extreme position B. At C, mechanical, we can write it as directly. So mechanical energy will be 10 joules. Reason you should write. Okay, reason, see, okay, here mechanical energy remains same as at B. Okay, at B, what is the mechanical energy? 10 joules. Okay, at B you can write it as, see, at B here you can write it as kinetic energy will be 0. So why kinetic energy is 0 at B? Why? Because it has no velocity. If it has no velocity, no kinetic energy, then sum of kinetic plus potential is equal to mechanical energy. So mechanical energy will be at C. At, yeah, see, if you create one more point here, D, any point mechanical energy will be same unless it is a frictionless medium. If it is a frictionless medium, then sum of the energy, how much percentage they are giving? 30% is lost. So 30% of energy is lost due to friction. Then remove the 30% here. How much is 30%? 3 joules. Then remaining will be 7 joules. 7 joules is the mechanical energy. If they mention 30% of energy is lost due to friction, if they don't mention, always we have to assume it as frictionless medium. This is done. Then we'll go for sub question C. What is the speed of the bob at the position A? Okay, at the position A when released from position B. See, when it is of frictionless medium, see, they have mentioned take G is equal to 10 meter per second square and there is no loss of energy. See, if there is a loss of energy, if there is no loss of energy, I'll train you in both the ways so that you will be perfect. We need to find the velocity of the bob, correct? So here, listen, here I told you whatever the kinetic energy we have, that will be maximum, that will be equal to potential energy here, correct? Because here potential energy is 0, kinetic energy is maximum. Here potential energy is maximum, kinetic energy will be 0. So at A, see, you need to write, at A you need to understand like this: kinetic energy will be equal to, kinetic energy at A will be equal to potential energy at B. Potential energy at B. So that is nothing but kinetic energy at A is equal to 10 joules. This is what you are going to write. So for kinetic energy we got. Now what we need to find? Velocity. Kinetic energy formula half mv square. Kinetic energy is equal to 10 is equal to half. What is mass? 0.2 into v square, correct? That is what we need to find. Now, so we can write it here. So what do we have? See, we are going to send this to that side, 0.2 below it, then 10 into 2 divided by 0.2 is equal to v square. Okay, so here, so if you solve this one, we'll get 100 is equal to v square. What do we want? V square or v? We want v. Send the square that side, it becomes square root. So square root of 100 will be 10. What is the 10? 10 meter per second. Velocity is equal to 10 meter per second. So just by having the concept, you can answer any kind of question. That's it. So here you have to focus mainly on the concept, where the potential energy is 0, where the kinetic energy will be 0, where we have both the values, all those things. See, this C will give you the proper idea. They are asking us to find the kinetic energy at A, but we don't know anything, correct? At A we know only one thing: kinetic energy will be maximum. That maximum value will be equal to the potential energy at B. Okay, then kinetic energy at B will be 0. So complete kinetic energy what we had, that is converted into potential energy at B. Then again when it comes like this, here height is 0, so whatever the potential energy we have here, that will be converted into kinetic energy. In this way I have written kinetic energy at A is equal to potential energy at B. So kinetic energy at A is equal to 10 joules. That is what we found here. The same thing. Then kinetic energy we got. We need to find velocity square. 10 we have joules. Half mass is given as 0.2 p square. So using all these things, find the value of V and write the proper unit. That's it. Now we'll move on to 2023. Calculate the power spent by a crane while lifting a load of mass 2000 kg at the velocity of 1.5 meter per second. Take G value as 10. See, this G value you have to take whatever they have given. See, sometimes they will give you 9.8, sometimes they'll give you 10. So if they don't mention, you can aramse take 10. If they have mentioned 9.8, you have to take 9.8 only. Okay, so what we need to find? Power. What is given? Mass is equal to 2000 kg and velocity is equal to meter per second. To find power, work done by time is the formula. Is time given? Then this is not the formula we are looking for. For power, we know we have one more formula, that is power is equal to F into V. Velocity, force. Velocity is given, force is now, okay, what is that velocity? That is 1.5. Okay, velocity given, force is not given. So we have mass. We know how to convert mass into force, correct? Newton. They have given G value as 10. So if you want to convert mass into force, whatever the G value they have given, mass into gravity value will be equal to force. What is mass? 2000 into 10. So that will be 20,000. What is the unit of force? That is Newton. Now we got the force, we have velocity, we can aramse find it. So force is equal to 20,000 into 1.5. That will be 30,000 watt. That's it. So the key thing is gravity value. If they have given 9.8, you have to take 9.8. Here gravity value they have given 10. That is why I have taken 10. Or else you're not going to get even single mark, because the substitution only wrong. First mark is always given for substitution. That will be wrong, because if they have given 9.8, you have taken 10. You should not assume it. Whatever the value they have given, you have to take that. If it is not given, then you have to assume it as 10. Our next question, a car of mass 120 kg is moving at a speed of 18 km per hour and it accelerates to attain the speed of 54 km per hour in 5 seconds. Calculate the work done and power. See, here many students will get confused. Why? Because we have to find work done and power. First we have to find work done, then only we can go for power. To find work done, they have given mass and velocity. How we can find it? So very simple thing. See, whenever they are talking about work done, they can talk about two things. One is work done related to potential energy, work done related to kinetic energy. If the object is moving, then work done is equal to kinetic energy. Keep this in mind. This is very much important. This is what we have understood in numerical solutions, correct? Whenever we are solving the complete textbook numericals, we have understood this one. If the object is moving, then work done is equal to kinetic energy. If the object is not moving, work done is equal to potential energy. These things you should know. Okay, this is the important part in this question. Here the object is moving, so work done is equal to kinetic energy. So first sub question, work done is equal to half mv square. This is the formula we are going to use. Okay, work done is equal to Fs cos theta. That is also correct. When the object is moving, okay, if they have given speed, see, in many cases also object will be moving, but at that case velocity will not be given in the question. When the velocity is given, work done will be equal to kinetic energy. And here we have, in this question they have given two velocities, so this will be half m v minus v square minus v square. So what is the first v we are talking about, which is the greater value? 54. So that is second velocity. According to the question, that is the second velocity. So this is v2 square minus v1 square. Okay, v2 square minus v1 square. See, some students will make mistake like this. Okay, half m v2 minus v1 whole square. This is completely wrong. See, this is a minus b whole square. This is a square minus b square. Completely wrong. So you have to be very careful with this one. Okay, it is not v2 minus v1 whole square, it is v2 square minus v1 square. Okay, this is very much important. Why I have taken v2 first? Why? Because it is greater. Correct. So if you know this method, aram se we can find the answer. Now 1 by 2 into what is the mass? 120. So in the bracket v2 square minus v1 square. What is v2? 54 square minus what is v1? 18 square. Correct. If you apply, we'll get an answer that will be completely wrong. Why? Because speed, see the unit, kilometer per hour. What is SI unit of speed? Meter per second. You have to convert this kilometer per hour into meter per second, then only you have to substitute in the calculation. Now, so 18 kilometer per hour, right? So how do you convert into meter per second? Meter per second, it is 5 by 18. 18 into 5 by 18. 18 get cancels. It is 5 meter per second. The first one we have converted. Okay, 18 meter per second. Then we have to calculate for 54. See, you don't have to calculate again like this. Okay, you can go for like that only, aram se. But see here, 18 3s are 54. So here it is 18 kilometer. The second one is 54 kilometer. So 3 times you have to multiply. What is the answer we got for 18 kilometer per hour? 5 meter per second. So 5 into 3, that is 15 meter per second is the conversion of 54 kilometer per hour, or else you can go for manual method like this also. So 54 into 5 by 18, 18 ones are 18 threes are 15 meter per second. So you don't have to waste time by calculating. So first one you convert it. Okay, 5 meter per second. What is the difference between these two? It is 3 times of this one, right? This answer will also be 3 times of that one. So 5 meter per second, 5 into 3, 15 meter per second. You can go for mind calculation or normal calculation, anything is fine. Okay, now we got the velocities. First v2 is 15 square, v1 is 5 square. Okay, half into 120. Okay, what is 15 square? That is 225. 225 minus 25, that is 200. Correct. 15 square minus 5 square. What is 15 square? 225. 225 minus 25, that is 200. So this ones are this. Okay, 60s are next. 6 2s are 12. Then 3 zeros. So what we have done? We have found the value of work done. Work done is done. Once the work done is done, then go for power. Power is equal to work done by time. What is work done? 12,000. Then what is the time they have given? 5 seconds, right? 5. Okay. Answer will be 2,400 watt. That's it. You need to be careful before substituting the values. It has to be in SI units, then only. And formula conversion, see here we have used many things, many tricks we have used. You need to understand that if the object is moving, then work done is equal to kinetic energy. If the object is not moving, okay, if the height is given, then go for work done is equal to potential energy. In this question they have given velocity. What if they have given height? If the height is given, we have to go for potential energy. What if they have given two heights? Then work done is equal to mg h minus h. Here h2 minus h1, or it can be h1 minus h2, whichever the value is greater. For that one we have to substitute first. So it can be h2 minus h1 or h1 minus h2. In this case also, see here it is half mv square. Why? Because velocity is given. So work done is equal to kinetic energy of mv square. So v square we have two values, correct? So it will not be v2 minus v1 whole square. It is v2 square minus v1 square. This one you have to be very careful. So why it is v2 first? Why not v1 first? Because v2 value is greater. That's why. Then substitute the values. See here again it is given in kilometer per hour. We have to convert into meter per second. Then we have to substitute, get the power value, work done value, then go for the power value. That's it. Our next question, name the physical quantity obtained by using the formula U by H. U by H, and where u is the potential energy, h is the height. This hint they have given, u is the potential energy. When we get to know it is related to potential energy or any other work done, power, anything, okay, the hint you have to go for the formula. U is equal to mgh. I think we have solved one question like this in a earlier question. So these kind of questions are very much important, 1 or 2 mark questions, easily you can get it. Now u is equal to mgh. According to the question, h is moved on the LHS, correct? So if you move h, what is the remaining thing? Mg. So that is what we want, correct? What is the physical quantity? But here we have two letters. Physical quantity means it will be having only one symbol, correct? Mg. There are two physical quantities, but how many physical quantities we want? We want one. These are the two things, but we want only one thing, that is two physical quantities we have to convert into one physical quantity. If you multiply mass into gravity, what do we get? That is nothing but weight. If we multiply mass into gravity, we'll get weight. So what is that? Weight. So in this question they have given name the physical quantity, but in some other questions they will confuse you, like earlier, name the unit of physical quantity. Unit of this physical quantity we need to find, but here it is clearly mentioned, it is name the physical quantities. So physical quantity is weight. If they mention in the question name the unit of physical quantity, then answer would have been Newton. Answer would have been Newton, because unit of this physical quantity is Newton. In this question they are just asking just the physical quantity. So weight is the final answer for this question. If they change, name the unit of physical quantity. What is the unit of physical quantity? Weight, that is Newton. Then you have to write Newton. These simple things you need to understand. Now we will move on to 2024. When a stone tied to a string is rotated in horizontal plane like this, a tension in the string provides. That is very much important. Dash force necessary for the circular motion. Assume a stone is tied and I am holding here this rope. Okay, that is nothing but the string is connected to the stone and the stone is rotating. The stone can be rotated in the anti-clockwise or clockwise, any direction, that is okay. Now they are asking what is the tensional force by the string provides. So this is the string, that is nothing but the rope, okay, holding the stone. Whenever it is rotating, the tensional force that is towards the center. Whenever object is moving in a circular motion, what is the force which is towards the center? In this question they have not given the word towards the center. Instead of that they have given the hint of tension of the string. Tension of the string is, we know, tensional force. Tensional force, in one of the question we have understood, tensional force will be towards the support. Where is the support? That is here, I am holding it. So I am holding the rope, that is the support, right? So tensional force will be towards it. So that is nothing but towards the center. Towards the center is nothing but centripetal force. Centripetal force. Okay, if it is away from the center, that will be centrifugal force. In this question they have not given center, it is away or towards. So we need to understand based on the tensional force. Tensional force is towards the center, so it is towards the center force we have to find, that is nothing but centripetal force. So this is sub question A and sub question B. Okay, work done by this force at any instant is. So work done by the force, see, now here what the answer will be, first I will write the answer, that is 0. Why it is 0? What is work done? Work done is equal to Fs cos theta. There is a force, the force is there, then displacement is also there, correct? Displacement, perpendicular distance is also there. It is not just Fs, it is Fs cos theta. What is the cos theta? Angle. So whenever the object is moving here, the angle will be here. Assume the object is moving here, okay, in this direction, the angle will be here at any instance, okay, and this is the perpendicular distance. This is the force, okay, direction of force at any instant. What is the angle? See, at any instant what is the angle? That is 90 degree. So in this question they are not asking for a reason, I am giving you reason if they ask in the future. So if any object is in moving circular motion, the work done will be 0. Why? Because the angle between the force and the displacement will be 90 degree. If it is 90 degree, Fs cos theta, cos theta is 90. What is cos 90? that is 0. Anything multiplied by 0 is 0. So work done whenever the object is moving in a circular path, it is 0. The reason is this one. That's it. Our next question. Samit does 600 joules of work in 10 minutes and Amit does 300 joules of work in 20 minutes. Calculate the ratio of powers delivered by them. So we have to find the ratio, that is nothing but we have to compare it. See, whenever it is a comparison related questions, you don't have to convert into SI units. I'll show you both the methods. Okay, you can convert into SI units and you, without converting also you'll get the same answer. I'll teach you both the methods. See what they have given. Samit, okay, Samit does work done. Okay, work done is equal to 600 joules and time taken is equal to 10 minutes. Okay, then Amit does 300 joules of work done is equal to 300 joules and time taken is 20 minutes. Now first we'll convert into SI unit, then I'll teach you without converting into SI units also we get the same answer. See, without converting into SI units, when we can get the correct answer? Only when it is related to ratio questions, comparison questions. If not, in all the numericals we have to convert into SI units. In this question we can convert without converting also, we'll get the same answer. Why? Because both the sides we have same unit, they'll get cancelled. So listen, I'll show you the proof. So SI unit here is 10 into 60, that is 600 seconds, correct? Here 20 minutes, so 20 into 60, that is 1200 seconds. So power of Samit is equal to, and we can aramse get the final answer like this: power of Samit by power of Amit. So power of Samit is equal to, that is work done by time taken by Samit, and here work done by time taken by Amit. What is that work done by Samit? That is 600 by 600, time is 600. Then here work done by Amit is 300 divided by time, that is 1200. So this one 600 by 600, instead of division we'll go for multiplication, then we have to take the reciprocal. So 1200 by 300, 0 zeros, 2 zeros, 2 zeros. See, 6 ones are 6 ones are, then 3 ones are 3 fours are. So answer is, see, on the numerator we have 4, denominator we have 1. So answer is 4:1. Once we got this one, see, this is our final answer. Now I'll show you without converting into SI units also we can get the same answer, only if it is a comparison or ratio form questions. See, power spent by Samit and power spent by Amit. So we'll directly go for the values. Work done is equal to 600 joules and the time without converting it is 10 minutes. Then work done by Amit is equal to power spent by Amit is equal to work done by Amit, that is 300 joules. He has taken time as 20 minutes. Next, 600 by time into, instead of division we'll go for multiplication, then it will be 20 by 300. 300 ones are 300 twos are, so 0 get cancelled, 4:1. You can go for any method. So my suggestion is, when it comes to comparison or ratio form, you don't have to convert into SI units, you can directly go there. That's it. Our next question, see, this is a diagram based question. You don't have to get panic. This is a very simple question compared to previous questions. Previous questions we had so many calculations. Here without calculations you can answer if you know the concept. Very simple, I'm going to teach you. See, in one of the questions we have learnt, that is what we are going to apply. Two identical marbles A and B. There are two identical marbles A and B. We have two different marbles A and B. We are going to roll it out, okay, are rolled down along path 1 and path 2 respectively. That means A is going to path 1, okay, path 1, right? This is path 1. A is going to path 1 and B is going to path 2. This is the condition. Path 1 is frictionless, path 2 is rough. So path 1, this path is frictionless, that side it is rough. This is the hint. Now, which marble will surely reach the next peak? See, we are rolling out marble A in path 1 and marble B in path 2. Path 2 is rough. So it is very difficult for marble B to reach the top. But the question is which will surely reach the peak, next peak. This is the peak for path 1 and this is the peak for part 2. Anyhow, part 2, the marble part 2 is rough. The marble may not reach, may not reach, but here in the question surely reach. That is obviously path 1, because path 1 is frictionless. That is, you can write it as which marble, right? Marble A. Just write A. That's it. You will get full marks. You don't have to write marble A also. Just write A. That is done. Then we'll go for second question. Along with path or paths, the mechanical energy will be conserved. See, mechanical energy, when it will be conserved, what do you mean by mechanical conservation of mechanical energy? Whenever a potential energy is converted into kinetic energy or kinetic energy is converted into potential energy, so mechanical energy remains constant only when it is a frictionless medium. This meaning you should know to answer these kind of questions. Okay, in which path mechanical energy will be conserved? Mechanical energy will be always conserved in the path where it is frictionless. Only in frictionless medium mechanical energy will be conserved. So that is, they are talking about with path, not the marble, right? With path or paths. So that is path 1. Okay, path 1, the mechanical energy will be conserved. Then, along which path or paths is the law of conservation of energy obeyed? Here they are not talking about mechanical energy. It is conservation of energy. That means general energy. So whenever they talk about general energy, that means it obeys both in frictionless as well as in rough medium. So whenever we talk about conservation of energy, it works in both frictionless as well as rough medium. But when it comes to law of conservation of only mechanical energy, the word mechanical energy, that works only in frictionless medium. So answer for sub question C is both the paths, or you can write it as path 1 and path 2. Both. Now we'll move on to 2025. When it comes to diagram based question, many students will get panic. But if you understand, first you need to know which concept it is related to, then it is easy to understand. Now see, Richa weighing, Richa is a girl, okay, she is skating, okay, Richa weighing 40 kg. The mass of Richa, okay, mass is equal to 40 kg. Actually it should be weight, okay, weight is equal to 40 kg. Then weight has two units, one is kgf, one it is Newton. When it is not related to gravity, it is kgf. If the weight is related to gravity, then it will be in Newton. So you have to be very careful. So kg, kgf is both are same. 1 kg is equal to 1 kgf. That is why I wrote mass. That is okay. We can go for it because given data there is no marks. Richa weighing 40 kgf leaves point P on her skating board and reaches Q on the ground with the velocity 10 meter per second. So at Q, okay, whenever she is moving from P to Q, the velocity is how much? 10 meter per second. Then calculate. So now we have to calculate kinetic energy at PQ, vertical height at P, that is height we have to calculate here, and here we need to find the kinetic energy, and when she reaches that side we have so many sub questions. Now listen, first we'll understand the question here. Now Richa, now she is here, okay, now she is not moving, so what energy she has? Potential energy, and she is not moving, so kinetic energy will be zero at this point. Whenever she starts moving, potential energy keeps on decreasing, correct? Why? Because the height is getting reduced, and how much potential energy is getting reduced, that much kinetic energy will be increased. When she reaches the bottom Q, there will be no potential energy. Why? Because height is 0. If the height is 0, potential energy will be 0 and kinetic energy will be maximum. Whatever the potential energy she had here, the same energy will be completely converted into kinetic energy here. And whenever she reaches here, she has both potential energy as well as kinetic energy. Why? Because see, we have height. When she reaches here, we have height, correct, and she will be moving with some speed. Then what will be the kinetic energy? So these conversions, okay, you should know. At this point she has only potential energy, no kinetic energy. At this point she has only kinetic energy, no potential energy. At this point we have both kinetic as well as potential. Okay, now because whenever she is moving, okay, while moving, they have never mentioned she has stopped at R. she has stopped at R. So that means we have both kinetic as well as potential. Kinetic because she is still moving, it is not mentioned, it is she has stopped, and it has height, so it has both potential as well as kinetic energy. This is the concept. Now we'll go for the first sub question. The kinetic energy of Richa at Q. At Q, we need to find the kinetic energy here. So first sub question, at Q we need to find the kinetic energy. What is the kinetic energy formula? Half mv square. Correct. Half, the value is there, no need to, this is a constant. Mass is given, velocity is also given. Find it. Okay, substitute it and get the answer. So half mass. Sometimes see, in some questions instead of giving kgf, they will give you in terms of Newton. They'll give you in terms of Newton. If they given in terms of Newton, you have to convert into mass and then substitute here, or else everything will become wrong, because first sub question is related to second, second is related to third, everything will become wrong. So first you need to know whether they are in SI units or not. 1 kg is equal to kgf. Mass is nothing but kg, correct? Unit is kg. So 40 kgf. In this case it works. Sometimes what if it is given as Richa's weight as 400 Newton. 400 Newton. If it is 400 Newton, if you substitute here, everything is wrong. So you have to convert this one into kg. Whenever we are converting from kg to Newton, we will multiply by 10. Kg to Newton, multiply by 10. Newton to kg, it is division by 10. So 400 by 10 will be equal to 40 kg. Then you have to use that as a mass. Now, so this is very much important. Focus on these things. Next, mass is given directly in this question, 40 kgf. We know kg is equal to kgf. We can say use it. 40. What is the velocity they have given? 10. 10 square is 100. 2 ones are 2 20s are. So 2 3 zeros joules. Kinetic energy is equal to 2000 joules. See, kinetic energy at what we are finding? Q. If we have Q, okay, at Q, kinetic energy will be 2000, potential energy will be 0. Why? Because no height. But I told you, whatever the kinetic energy we have, the same potential energy we have at P. So here at P also, potential will be 2000, kinetic energy will be 0. Like this you need to understand. Okay, the first question is done. We'll go for the second one. The vertical height of P above the ground. Vertical height of P. Okay, height at P we need to calculate. So for height, if they are talking about height, we have to talk about potential energy. If they are talking about velocity, we have to talk about kinetic energy. So if this question is related to potential energy because they are talking about height. So to find height, okay, what is the potential energy formula? U is equal to mgh. M is given, G is given, height we need to find. We don't know what is U. U is nothing but potential energy. Where? At P. I just now I told you whatever the kinetic energy we have here, okay, kinetic energy is maximum, potential energy is 0 because no height. Whatever the kinetic energy we have here, the same potential energy, so is equal to some value. Kinetic energy will be 0 because it's not moving. Okay, she is not moving. Whatever the kinetic energy we have, the same potential energy we have, so that is nothing but 2000 joules. You don't have to give reason, it is understood. Next, M40. Again, if mass is given in terms of Newton, you have to convert into mass. Okay, Newton is given divided by 10. Okay, like whatever the gravity value they have given. If the gravity value is given as 9.8, you have to divide it by 9.8. If it is 10, you have to divide it by 10. Then you will convert it into mass. That you have to substitute here. Mass, gravity, height we need to find. So here H is equal to 2000. Send 40 and 10 that side, 40 and 10, 1 0 1 0 2 zeros, 4 ones are 4 5s are, so that is nothing but 5 meter. So this height is 5 meter. That is what we found just now. That is the question number B, sub question B. Now we'll move on to question C. Okay, that is sub question C. The kinetic energy of Richa at R, point R. So we need to find kinetic energy of Richa at this point. At this point, I told you earlier, we have both kinetic energy as well as potential energy. Why we have kinetic energy? Because she is moving from Q to R. She has not stopped, correct? She is still moving. Then why do we have potential energy? Because we have height. We have both kinetic energy as well as potential energy at R, and we are talking about point Q to R. So we have to talk about only these 2 points. At this point, we have only kinetic energy, no potential energy. So this kinetic plus potential will be equal to kinetic plus potential energy at R, correct? And they have mentioned one more thing: while moving from point Q to R, she loses 500 joules of energy against friction. This is very much important, that we can do later. Now see here, kinetic plus potential is nothing but mechanical energy. Mechanical energy at Q is equal to mechanical energy at R, that we know, correct? Because mechanical energy remains everywhere, same everywhere, and there is a friction, but that we are going to subtract that friction at the end. But mechanical energy at Q will be equal to mechanical energy at R if there is no friction. In the question they have made 500 joules of energy is lost because of friction, that will subtract it later. First we'll find mechanical energy at Q. So for sub question C, mechanical energy at Q will be equal to mechanical energy at R. This you should know. What is mechanical energy? K plus U at Q is equal to K plus U at R, correct? So now we got this one, and finally we have to subtract from 500. Why? Because 500 joules of energy is lost because of friction. That will do finally. Now we'll solve only these two. Kinetic energy at Q. Q means, that is what we have found. Kinetic energy at Q is 2000. We know at Q there is no height, potential energy will be 0. Kinetic energy at R, that is what we need to find according to the question. We'll write it as it is. Okay, then U means potential energy at R. We don't know that, but we have height, mass, gravity, that is nothing but mgh. Okay, then finally we are going to subtract it from minus. You don't have to write in every step, finally you can subtract it. Okay, whatever the answer we get, we'll subtract it from 500, we'll get the final answer. Now here we want K. What is mgh? Mass 40 into 10 into height. What height? It is U at R, right? This height we have to take. At R, whatever the height we have, that height we have to take. So it is 2000. This plus, if you send that side, that is minus mgh, 40 into 10 into height, that is 3. Now you subtract it. 2000 minus 1200, so that will be equal to 800 joules. So this is the kinetic energy at R, but 500 joules of energy is lost. So finally we have to subtract it from 500, that is 300 joules. That's it. So if you miss this 500 at the end, that is completely wrong. This one, see, these two are almost simple, but at C you have to be very careful. So at Q to R she is moving, and we know mechanical energy at Q will be equal to mechanical energy at R, and there is a 500 joules of loss of energy because of friction, that will do at the end. These are simple. Okay, mechanical energy means K plus U at Q. Mechanical energy at R is nothing but K plus U. Substitute the values, get the answer. Finally, don't forget to subtract with the loss of energy. Now we have completed work energy power related previous year papers from 2017 to 2025. See, work energy power, maximum of 4 to 5 mark questions will be there in the board paper. So these kind of questions every year, based on this mechanical to kinetic, kinetic to mechanical conversions, every year there will be one question. Okay, so if you know all these knowledge, so we have not only learned the answer for one particular question, we have learned the complete concept. So whatever the questions they create, you apply the knowledge we have learned, you will get the answer. So how to get the complete knowledge of a particular chapter? In work energy power we have 3 parts. In all the 3 parts, concepts, theory, numericals. In all the 3 parts, if you learn all these things, okay, concept, theory and numericals, then you come to previous year papers. Now you will understand here how the questions are different from textbook questions. Then whatever the knowledge we have gained from the concept, theory and numericals, will apply it here. Now we'll get to know what kind of questions. Here we are not just learning the solutions for a particular particular questions. We are learning in all the directions, all the angles, so that whatever the questions they can twist, let them twist. We have the knowledge, we'll apply it and get the answer. After this one, go to the logical and application questions. These questions are taken from specimen papers and competitive based questions which is released by ICSE only. This is the proper way of understanding physics in ICSE. Thank you.